Okay, so I want to walk through another example. And again, assuming that we don't remember a whole lot from last semester, or last year, I should say, in graphing these and kind of just talking through and walking through it in a little bit of an extended fashion. Eventually, we'll be at a point where we don't have to be, thinking about step by step by step. We'll kind of see it and know what to do. But I do want to emphasize a few things. So as I want to sketch the graph of this function, again, like I said in the last video, I want to look at the local behavior, but also end behavior. And so local behavior, I'm going to use the x-intercepts to determine. So there's my x-axis, y-axis. So I know that -5 is definitely a 0. So I'll go ahead and put that there as x equals -5. And it doesn't have to be like drawn to scale. If you think of my last example, 27 looked smaller than 2, in terms of a distance. So it's not drawn to scale. I have an intercept at 8. So over here, x equals 8. And then right here, this one is a little bit of deceiving or in disguise. That actually is going to give me another intercept. And it's going to give me an intercept of 0, because when I let x be 0, -0, which is still 0, makes the entire thing 0. So I know that I have an intercept here at x equals 0. Now, having an x-intercept 0 is awesome because it's also a bonus, a y-intercept, right? So, and since these are functions, we'll only have one y-intercept. So we found it, which is great. So that's the behavior. And if you look at the multiplicity, I've got even, odd. So at x equals 5, -5, I should say, when x is -5, my multiplicity is even. Remember, the behavior of an even is a parabola, either opening up or opening down. When x is 8, my multiplicity is also even. And so again, it's either opening up or opening down. And then at x equals 0, my multiplicity is odd. And again, odd because it's understood 1 as the exponent. Remember, odd is going to intersect one way or the other. Now, since this is odd being linear, right, a power of 1, it's not going to have that little squiggle in it. It's just going to go straight through, top to bottom or bottom to top. Okay. Now, we have the x-intercepts, the y-intercepts. The next step really is to determine that power function, right? So my power function would be the highest power, I should say, if we were to expand everything. And so like this term at the end here will give you an x squared. This will give you another x squared. So multiply together in distributing, they'll give you x to the 4th power. And then this one right here is linear, so it's x to the 5th. But it has a coefficient in front. So our power function, I would say, is negative x to the 5th. Okay, so now it's an odd number, but it's negative. So what behavior does that look like? Well, if you go back to what you wrote down before, a power function that is a negative odd looks like this. So you're starting in the upper left and going to the lower right. So I know that the shape is going to start over here somewhere and end down here. And I'm using that as a starting location and ending location, and then approaching each 0 in the appropriate behavior. So -5 is even. We need a parabola shape. So let's go, I guess, use red. We're starting here. We need to just touch and go, bounce, and come back up. Then when we get to 0, I know I have to intersect right through. So I'm going to go straight through. And then I need to get x equals 8. Again, touch and go. But I realize I've got to end in the lower right corner. So when I touch and go, I have to do something like that. So I get a general shape, putting arrows there, of this function. Use green and highlight that shape. Okay, now here's the thing. There are things we don't know about this graph, and that's okay, right? I think I mentioned in the last video. It's okay that we don't know how high this is, okay? It's okay we don't know how low that is. And I mentioned this on the first day of class. In my head, in my world, I'm split between honors pre-calc in the morning. That's where that's what I think about. And in the afternoon, calculus. And when we get to calculus, we are going to be able to find these points without a calculator, which is so exciting. But for now, we just have a sketch of them, and we could use a calculator to find those maximum minimum values. Okay, excellent. So I'd like to look through, I think there's one more example I want to do. Let's look at example 3, okay? And again, maybe we'll be going through it a little bit quicker because we have a little bit more practice under our belt. But when I see example 3, I see 3 zeros. So again, I wanna think about, well, where are they at? What's the behavior? So the first one, a 0 actually is happening at 0. Right? Because even with a -2 in front, x cubed is still a 0 when x is 0. So I know that that's a value. And bonus, it's a y-intercept. I also have -2. And I also have 4. Okay, so those are my 3 x-intercepts. Also a y-intercept for free, which is nice. Now, let's talk about the overall behavior of this function, the power function, right? So my power function, I'll call it p of x, would be all of the, if I were to multiply this out, what's the lead term? I'm multiplying all the x's and coefficients in front. So there's an x to the 4th that would have gone here, another x, that's x to the 5th, x to the 3rd, so that's x to the 8th. So it's not just x to the 8th, though, because there was also a coefficient of -2. And that would be the very first lead term if I were to expand everything out. Now, the 2 is not as significant for me right now as the negative, right? The negative tells me it's a negative even function. A coefficient of 2 just vertically stretching it. We're increasing twice as fast. But it's the negative that I want to focus on. A negative even coefficient, negative even, starts in the lower left, ends in the lower right. So I know that my graph must start down here and end here, okay? And then I look at the behavior of -2. The behavior at -2 is odd multiplicity, right? Because the exponent is 1. And it's 1, so it's linear. So I'm going to actually start here and go right through there and realize I got to get back to 0. And notice that 0 has odd multiplicity as well with cubes. So it has to have that little squiggle. So I'm going to come up, squiggle through 0. Again, how high do you go? Well, we don't really know just yet until we learn some calculus. And then I gotta get back to 4. Multiplicity is even, so I gotta go down. How far low? I don't know. But eventually go back up there. And again, because it's a 4, it should be flatter than a 2. But again, it's just a sketch. And we come back down, since it's just touch and go. But also, it's great because that's where it says we should end. So again, we start. We go straight through at -2. We do a little wiggle at 0, and we come up to 4 and go back down. And again, things that we don't know. We don't know how high that is, and that's okay. We don't know how low this is, and that's okay. Right? Okay, excellent. So again, important things and expectations that we need to know for this particular topic. So let me know if you have any questions on this video. Otherwise, very nice job.